In the summer of 1966, an American spy satellite passing over the isolated waters of the Caspian Sea captured an image that defied the rules of aviation. Sitting on the water was a machine of impossible proportions. It was nearly 100 meters long, vastly larger than any aircraft in existence. Yet its wings were short, stubby rectangles that looked completely incapable of generating flight. Even more terrifying were the speed calculations. This 500-ton colossus was moving across the water at well over 300 miles per hour. It wasn't a boat. Its hull was entirely out of the water. But it wasn't a conventional airplane either. It never flew higher than the height of its own wingspan. Stamped on its nose were the letters KM. In Washington, stunned intelligence analysts dubbed it the Caspian Sea Monster. To the Soviet military, it was a hybrid vehicle designed to exploit a literal loophole in the laws of fluid dynamics. It was a machine that refused to belong to the sky, and a ship that refused to touch the sea. It flew by weaponizing a phenomenon known as the ground effect.
To understand the physics of this monster, you have to realize that a standard airplane wing is highly inefficient. As a plane flies, air curls around the wingtips, creating violent, invisible mini-tornadoes called wingtip vortices. These vortices generate massive aerodynamic drag, pulling backward on the plane like an invisible parachute. But when an aircraft flies extremely close to a flat surface, the behavior of the air completely changes. As the wing moves forward, it pushes down a massive volume of air. Close to the ocean, this downward moving air hits the water and has nowhere to go. It becomes physically trapped and compressed beneath the wing, turning into a dense, high-pressure cushion. Think of it like an inverted air hockey table. Instead of the table blowing air up, the vehicle's own speed compresses the air beneath it, creating its own invisible cushion of lift. This physical proximity to the water blocks the wingtip drag from forming, making the wing unbelievably efficient. As long as the aircraft stays trapped within this thin layer of compressed atmosphere, it can carry payloads that would cause a normal plane to instantly stall and crash. Building a machine to live inside this aerodynamic glitch required throwing away the aerospace rulebook. The KM was a structural titan, weighing a staggering 544 tons at maximum takeoff. To move this mountain of steel, engineers installed 10 massive turbojet engines. But it's where they placed them that reveals the core engineering problem. 8 of the engines were bolted together in a giant row right on the nose of the aircraft. Why place 8 jet engines on the nose? Because water is sticky. The greatest enemy of a ground effect vehicle is hydrodynamic drag. When stationary, the massive boat-like hull suffered from intense water suction. To reach the speeds required to generate the aerodynamic cushion, it had to break free. During takeoff, the pilot tilted the nozzles of those nose engines downward. The roaring exhaust blasted high-velocity gas directly underneath the wings. This artificially forced a high-pressure cushion while the vehicle was barely moving, literally lifting the monster out of the water's grip. Once airborne, the nose engines were throttled down, leaving the tail engines to cruise with unprecedented fuel efficiency.
The Soviet Union didn't build the Ekranoplan for science. They built it to neutralize the United States Navy. During the Cold War, American carrier strike groups dominated the oceans with advanced long-range radar and sonar networks. Traditional Soviet warships were too slow to approach them, and bombers were easily detected high in the sky. The Ekranoplan was the ultimate structural ghost. Because it flew at 350 miles per hour, it could cross an entire sea in hours. Yet, because its altitude was locked at a mere 15 feet above the waves, it flew completely beneath the minimum detection horizon of Western early warning radars. The radar waves simply bounced off the curved horizon, leaving the incoming monster completely invisible. Furthermore, because the hull never touched the water during flight, it was completely immune to acoustic sonar, torpedoes, and sea mines. It could scream across the sea, undetected, pop up over the horizon, unleash a battery of nuclear-capable supersonic cruise missiles, and vanish back into the mist before the enemy could scramble defense jets.
If the tactical advantages were so overwhelming, why are the seas empty of Ekranoplans today? Because the exact same physics that gave the monster life also set a deadly mechanical trap. The ground effect cushion only functions if the surface remains perfectly flat. While the Caspian Sea is sheltered, open oceans are filled with unpredictable, massive waves. If a wave slammed into the low-slung wings at 300 miles per hour, it meant instant structural destruction. Worse was the problem of aerodynamic pitch instability. If the pilot pulled the nose up even slightly, the front of the wing would leave the ground effect, instantly losing its lift. Meanwhile, the rear of the wing remained trapped in the high-pressure cushion. This caused the tail to lift violently, forcing the nose to pitch down sharply into a catastrophic, high-speed dive directly into the water. Combined with the constant ingestion of corrosive, salty sea spray into the jet engines, the maintenance and operational risks became unsustainable.
The end of the Caspian Sea Monster was as violent as its design. In 1980, a test pilot ignored strict pitch protocols and pulled the nose up too steeply during a high-speed maneuver. The monster instantly lost its cushion, stalled, and slammed violently into the water. The hull fractured, and the largest aircraft the world had ever seen sank to the bottom of the sea. With the collapse of the Soviet Union, funding completely evaporated, leaving these radical machines behind as artifacts of a lost empire. Today, on a desolate beach near Derbent, Dagestan, the lone surviving cousin of the monster sits resting in the sand. Its giant turbojets are silent, covered in rust and bird nests. Its missile tubes point toward an empty sky, washed by the gentle tides of the Caspian Sea. The Caspian Sea Monster stands as absolute proof that high-end engineering isn't always about choosing between land, air, or sea.
Sometimes, to conquer the speed barrier, you don't build a better boat, and you don't build a better plane. You find the glitch in the middle, build a 500-ton monster to live inside it, and accept the reality that you must be willing to fly on a cushion of trapped air. This